Page 492, lesson 8.2 is on multiplying and factoring. So if you look here, mentions about how you can use distributive property to multiply a monomial by a polynomial. You can see the picture, but otherwise just by this, you guys can just remember how we use distributive property. We multiplied to the things inside the parentheses, if inside the parentheses they're adding or subtracting. So if you look at problem 1, they're asking what's a simpler form of that. So simpler form of that would be if you distribute. What's a little different on these problems maybe than some things we've done in the past? We've got more exponents and things maybe than what we've had before. Remember, when you multiply like bases, you add the exponents together. So if I multiply negative x cubed times 9x to the 4th power, I'm just adding those exponents you can see here. So I add those, remember, would be negative 9x to the 7th power. And then same idea for the other parts. Here is a negative times a negative would be a positive 2x to the 6th power, and then minus 7x cubed. So then that matches up with answer choice D. So we can do the same thing with the got it. They're just asking what a simpler form of that is. So that would just be us distributing. This one, we're not distributing a negative term, so that makes things a little simpler. Watching our signs when we work this out. So when you distribute, if you want to put a little 1 exponent next to these n's, you can. And this first part, 5 times 3 is 15. And then if we do n times n cubed, we're adding those exponents. So we have 1 factor of n times n cubed, which is like 3 more factors of n. Altogether, that's 4 factors of n. So that would be n to the 4th. Again, you can just add those exponents together. And then minus, same thing here. This would be 5n to the 3rd power, or 5n cubed, and then plus 40n. The top of the next page, they are talking about factoring. So we've talked about this a little bit already. When we talk about factoring, it's kind of like we are pulling out the GCF, okay? Not mathematical terms there, but pull out the GCF, or I've called before undistributing, okay? It's kind of the reverse process, like this is what we had. What would it have been before we distributed in order to get that is another way of looking at it. Okay, so if you look at problem 2, they're just asking what the greatest common factor is there. So looking at the number part, we can see those all have a 5 in common. And then if you look at the variable parts, with the variables, basically we're just going to look for the lowest exponent, whatever has the least factors of x in it, and just a plain x would be it. So 5x would be our greatest common factor. They're not asking us yet to actually factor that out. They're just asking what it is. So we'll just stop there on that problem. So then the got it 2, same idea. Looking for the greatest common factor. So looking at the numbers, the 3, the 9, and the 12 are all divisible by 3. 3 is our smallest number, so that's going to be the biggest possible number we could factor out. And then with the variables, same idea. We're looking for the smallest, or the x with the smallest exponent, I guess we could say, and that would just be the plain x. So 3x would be our greatest common factor for this problem. So if we look at problem 3, we're going to actually work this out now. So first we're looking for the greatest common factor. So they're asking for the factored form of this. So first of all, if you look at the numbers, you can do what the book did. Otherwise, if you can just look at it and figure it out, that 4 would be the greatest common factor with the numbers, that's fine. And then notice here again we have just a plain x. That will be our GCF for the x parts. I said look for the lowest exponent on the x's, but this wasn't the problem. But if this would have been a +7 at the end, we actually would not be able to factor out an x because the 7 doesn't even have an x to factor out. Does that make sense? Okay, so even though I said look for the lowest, the one with the lowest exponent, if there's one that doesn't even have a variable, then you can't factor out a variable part on that problem. Okay, that's not part of the problem, but anyway. So this one we can do the x as well. So 4x would be the greatest common factor. And they factored it out. If you want to do what the book's doing, you can. I kind of just go straight to this. But if you want to do the in-between steps like the book's doing, basically I'm thinking about if we factor out a 4x. So multiplying all those together then should get us back to what we had originally. That 4x to the 5th minus 24x cubed plus 8x. Something else to think about when you guys do these problems is after you factor out your GCF, look at what you still have in the parentheses. If what you factored out actually was the GCF, then the GCF of what's left in the parentheses should be 1. There shouldn't be anything in common other than a 1 for what's left in the parentheses if we did this correctly. And that's the case here, so we're good with our answer for this problem. So if we look at the got it 3a, same idea is we are trying to factor this thing. So we can look at the numbers and we can look at the variables, factor out, find our GCF, and then see what we would have left. So with the numbers, we have a 3 in common. All the numbers could be divided by 3, and they couldn't all be divided by anything more than that. With the variables, these all have x's with them. The lowest one is x squared. So that's the most that we can factor out. So 3x squared would be our GCF, greatest common factor here, and then we'll see about if we distribute to get what we had to start with. So 3x squared times what to get 9x to the 6th? So 3x to the 4th is what we would be left with there. If we multiply, that would give us the 9x to the 6th. Same thing for the middle term here. 3x squared times what to get 15x to the 4th? And that would be 5x squared. And then the last term, 3x squared times what to get 12x squared? And that would be 4. Again, if we want to double check these, make sure there's nothing else in common that we missed. 3, 5, and 4 don't have anything in common. And then this last term, notice, doesn't have an x term, so there's no other x that we could have factored out higher than what we already did. The other check you can do after that would be to actually distribute that if you have time. Distribute it, and you should get back to what you started with. So if you look at part B, they're asking what is that written as the product of a polynomial with positive coefficients and a monomial. So polynomial with positive coefficients, in other words, our polynomial is what's in the parentheses. For that to have positive coefficients, we're going to have to factor out a negative number, okay? So we're just going to factor a negative. If you look at the numbers, 6, 18, and 12 all have a 6 in common. X to the 4th, x cubed, and x squared all would have an x squared in common. And then we could see what we would have left. So for our first term, we've got to get to negative 6x to the 4th. So we've got the negative 6 already. If you want to put a 1 here, you can. If you don't, that's fine also. And then x squared, we need times x squared to get to x to the 4th. Plus 3x here, where if we multiplied those would give us minus 18x cubed. And then the last part would be plus 2 to get to negative 12x squared. So this would be our answer for part B. Example 4, a helicopter landing pad or helipad is sometimes marked with a circle inside a square so that it is visible from the air. What is the area of the shaded region of the helipad at the right? Write your answer in factored form. So basically what we've got here is the shaded region is this part on the outside shaded in red, you can see. So basically what we're going to do is this is kind of going to be what I call a donut problem. Basically we're going to take what the area of the square is, and then we're going to find the area of the circle and subtract that from the area of the square. So it's kind of like starting with this whole thing and then taking the middle part out, okay, kind of like a donut. So the first thing they did is found the area of the shaded region. This is a rectangle, a square more specifically, so length and width are both 2x. We could have just done length times width, 2x times 2x if you wanted. That would be 4x squared is the area of the square, and then the area of the circle, pi r squared. The radius is x, so pi x squared would be the area of the circle. And then what we're doing, taking the area of the square minus the area of the circle. So 4x squared minus pi x squared. And then the greatest common factor is x squared. So they just factored the x squared out, and they got x squared times the quantity 4 minus pi. So just to look at another problem similar to that one, let's say this was all shaded on the outside here. This is 3r, and then the radius of our circle is r, and they want us to find the area of this shaded part. So the shaded part, we'll first look at the whole thing. This is a square, so 3r and 3r would be the length and the width, so that would be 9r squared. This circle, area of a circle is pi r squared, and in this case r is just r, so pi r squared. And then to find the area of the shaded part, it's the whole thing minus the middle part. With this, would have an r squared in common, and it'd be r squared times the quantity 9 minus pi. So really a very similar example to what they just had in the book, but just giving you another example of that. If you look at the lesson check number 4, they want us to factor that. So looking at those numbers, 4, 8, and 12 all have a 4 in common. And if you look at the variables, they all have at least an x, so we could factor out a 4x. And then that would leave us with x squared plus 2x plus 3. And again, make sure there's nothing still in common in the parentheses here. And then also make sure when you distribute, it gives you what you started with. One more problem I want to look at that's not in your book is if we have negative 15x to the 4th plus 6x cubed minus 12x squared. If you have a problem like this where you have a negative coefficient on your first term here, if this is in order from highest to lowest powers, this is called the leading coefficient, this negative 15. So if this is a negative number, then we're going to go ahead and factor a negative out for sure. We'll talk more about that later in the chapter, why that's the case, why it's going to be better for you to factor the negative out and not have a negative on your first coefficient in the parentheses. If you look at the numbers then, 15, 6, and 12, those all have a 3 in common. With the variables, we've got at least an x squared in all of those. So negative 3x squared would be our GCF. And then think about negative 3 times what to get negative 15? That would be 5. X squared times what to get x to the 4th? That would be x squared. This next part, negative 3 times what to get a positive 6? Negative 3 times negative 2 would be a positive 6, and then x squared times x is x cubed. And then the last part, negative 3 times what to get negative 12? That would be 4. And then we already have the x squared. So this would be our factored form for that problem. So this gives you an idea of how to work with multiplying and factoring.